Hello everyone, welcome to my channel. In the previous two videos on limits, I evaluated limits from 1 up to 10, and I promised I was going to come back and work on number 11 and number 12. And that's what I want to do in this video. Now, if you're new to this channel, please subscribe. Your support is much appreciated. Right, let's look at number 1 now, which is our question number 1, number 11 in the entire set of questions on limits. So number 11 here says we're supposed to evaluate the limit as x approaches minus infinity of the square root of x squared plus 2x and then plus x, like that. Now the way that we deal with these questions is by taking advantage of what we call conjugates. In simple terms, difference of two squares. So what do we mean then? Here's what we mean. If I say to you factorize a squared minus b squared, you are going to say to me that the answer is the square root of a squared is a, the square root of b squared is b in one bracket, and then in another bracket these two numbers must just subtract, like so. And so if I say to you factorize a minus b, you would say, well, by using this understanding here, we're going to say the square root of a is square root of a, square root of b is square root of b. We add them, and then in another bracket these two guys must just subtract, square root of a minus square root of b. So these two are what we call conjugates. Those two are what we call conjugates. Now you understand that we are taking advantage of what we call difference of two squares. So this is the approach we're going to take here. So we'll have to multiply by the conjugate of this. And because we don't want to change that, we're going to have to divide by the same number or same expression. So this is going to be limit. Watch what I'm going to do now. Limit as x approaches minus infinity of what? Of, watch this. I'm going to use a bigger bracket here now. Square root of x squared plus 2x plus x in one bracket. In another bracket, I'm going to have square root of x squared plus 2x. Then the conjugate is minus x. Right, we have to divide by this expression so that we don't change that limit there. Square root of x squared plus 2x minus x, like that. So that if you want, you can cancel these two out and you still have your original limit there. But we're not cancelling because we want to take advantage of difference of two squares in the numerator. So this is going to be a limit as x approaches minus infinity. Notice the numerator now, how it changes. It will be square root of x squared plus 2x, and then I'm going to have to square this, and I'm going to say minus x squared. If you follow what's going on here, follow what's going on. This form here, or this form, is exactly what you see in the numerator there. And the way that we deal with that is by squaring each term of these two and then subtracting them, like this. Right, so in the denominator we still have square root of x squared plus 2x, and then we are supposed to say minus x, like that. Now the numerator, you can see that it simplifies. We have limit as x approaches minus infinity. The numerator simplifies to x squared plus 2x minus x squared, all over square root of x squared plus 2x and then minus x, like that. Now obviously you can see that this cancels that, so that's why you have this. And then the x squared cancels x squared. In the numerator we only have 2x left, so limit as x approaches minus infinity of 2x all over square root of x squared plus 2x minus x, like that. Now I'm going to factorize this expression under the square root sign by taking our x squared as a common factor, or taking x squared as common factor. Let me move this one down a bit. Right, so I'm now saying this is equal to limit as x approaches minus infinity of what? Of 2x in the numerator. In the denominator now I'm going to have x squared, open brackets, x squared into x squared is 1, plus x squared into 2x, it will be 2 over x. X squared into 2x, this x squared into 2x, it will be 2 over x. And then I'll close the bracket. Remember, it's under the squared sign, like so. And then we have minus x there. Now, the x squared outside of these brackets here, I can take it out. But when I'm taking square root of that, I'm interested in the positive square root of that. So I'm going to use absolute value sign. Why? Because you can't have a square root of a negative number and still have a real number as your result or your solution. So this is going to be equal to limit as x approaches minus infinity of 2x in the numerator, and in the denominator now we have the absolute value of x times square root of 1 plus 2 over x and then minus x, like that. Now don't forget the absolute value definition. Absolute value of x is equal to x if x is positive minus x if x is negative. Now when you look at this limit, it's a limit as x approaches minus infinity. We're dealing with negative values of x, and therefore this should take the place of the absolute value sign there, or absolute value expression. Absolute value of x must be replaced by minus x. So this limit then simplifies to limit as x approaches minus infinity of 2x all over 2x all over minus x square root of 1 plus 2 over x minus x, like that. Now you can see that in the denominator we have a common factor, which is x. Take it out. Taking that common factor out, we have limit as x approaches minus infinity of 2x all over x, open brackets, this x is not clearly seen, all right, minus square root of 1 plus 2 over x and then minus 1, like this. What am I saying? I'm saying x into minus x times this is just minus that, like you can see here, and then x into minus x is minus 1. Now this x cancels that x. I'm not very happy with this, how this x looks here, because it's not very clear. Let me just clean up a little bit, right? And I'm going to use my bracket here. I'm going to clean up here also, right? So you can see clearly that we're dealing with x there, right? I'm going to rewrite it. So I'm saying here, let's have our bracket like that. Fantastic. Now this x cancels that x. What are we left with? So what we're left with is the following. It takes me to page number 3. Now we are left with, right, I'm gonna just make sure that this is in correct order here. Move it down a little bit. Right, so now I'm basically saying that what we have now is that is equal to limit as x approaches minus infinity of what? The x cancels, so I'm going to have 2 in the numerator all over minus square root of 1 plus 2 over x, then minus 1. Now notice something here. As x approaches minus infinity, 2 over x approaches 0. So therefore this can be rewritten as, in the numerator, 2 all over minus square root of 1 plus 0 minus 1, like that. And what does this simplify to? It simplifies to 2 over minus 1 minus 1, and this is, of course, that's 1 plus 0 is 1. What is minus square root of 1? It will be minus 1, and then you have minus 1 there. So this will be 2 over minus 2, and your final solution is minus 1. So that is the solution to the first limit. Not very straightforward, a little bit involving, but with patience and practice, you should be able to handle these questions. Right. Let's move on to question number 2 in this video. Question number 12 in if you consider all the questions we've had to look at so far. And our last question is question number 2, which is basically 12 here. We are supposed to evaluate the limit as theta approaches 0 of sine 5 theta over sine 2 theta. Now, to deal with this, we take advantage of a very important result with regards to limits of trig expressions. The limit as x approaches, I'm using x now, 0 of sine x over x is the same as limit as x approaches 0 of x over sine x, and this is actually equal to 1. Never forget this very serious result. You can prove this by using L'Hopital's rule or geometric methods. Now, for the sake of this video, I'm just going to explain it by using L'Hopital's rule. Basically, if you have the indeterminate form 0 over 0, you can differentiate the numerator, differentiate the denominator, then take the limit. Now, if you plug in 0 here, sine of 0 is 0. It will be 0 all over 0, indeterminate. That means L'Hopital's rule allows us to differentiate the numerator, and we're going to get cosine of x. Differentiate the denominator, you're going to get 1. And if you take the limit now, as x approaches 0, this will give you cosine of 0. What is cosine of 0? 1. Same story here. If you differentiate the numerator, you're going to get 1. Denominator cos x. And then it will be 1 over cos x. Basically, the reciprocal of this one here, which still gives you 1. All right, so this is the result we're taking advantage of. Now, you can have something trickier than straight like this, where you are, instead of having sine x over x, you have sine of 5x over 5x, like this. But you're told limit as x approaches 0, as you see in the question we have here now. Now, the understanding is, as x approaches 0, 5x should also approach 0, because you're basically multiplying x by 5, multiply 0 by 5. So this is exactly the same as limit as 5x approaches 0 of sine 5x over 5x. Notice something here. This, you can replace it with theta, and that will be theta, and that will be theta, and that will be theta. So it will be limit as theta approaches 0 of sine theta over theta. The answer will be 1. Not very nice way of presenting it, but I'm showing you there basically that the 5x can turn into theta. All right, let's see how we handle this one. So let's tackle our question number 12, number 2 in this video, and our last one. So this is the limit as theta approaches 0 of sine of 5 theta over sine of 2 theta. I'm going to split these as follows. This is the limit as theta approaches 0 of sine of 5 theta over 1, and then I'm going to say times 1 over sine 2 theta. Same expression, but if you recall here, I need to have that expression in the denominator. If I have 5 something here, I must have 5 something down there. So I'm going to have to divide by 5 theta. I have to multiply by 5 theta so that I don't change anything, this part here. And I'm going to have to put 2 theta there, and then I'm going to have to divide, because I don't want to change that expression, as follows. So this is the limit as theta approaches 0 of sine of 5 theta all over 5 theta, and then I'm going to say times 5 theta over 1. See, that expression is exactly this one, because this can cancel. You can have sine 5 theta over 1, which is exactly what you have there. And then I'm going to say times 2 theta over sine of 2 theta, but I don't want to change this, so I'm going to say times 1 over 2 theta. Watch that. So now this can cancel. I still have 1 over sine 2 theta, and this can cancel. I still have sine 5 theta over 1, which basically is what we have there at the beginning. All right, so what do we do next? I'm going to combine now this one and that one. I'll leave this one, these two as they are, but I'm going to take these two guys to the left. So this is going to be limit as theta approaches 0 of, watch this, 5 theta over 2 theta. And then I'm going to say times sine of 5 theta over 5 theta times 2 theta over sine of 2 theta, like that. And these cancel, obviously. We have 5 over 2, It's a constant, we can take it out. 5 over 2 times limit as theta approaches 0 of what? Of 5 theta sine of 5 theta over 5 theta times 2 theta over sine of 2 theta, like that. Now, properties of limits. The limit of a product is the product of limits. So I'm going to take this limit across, or multiply, take a limit of this and take limit of that and multiply the two. So this is 5 over 2 times the limit as theta approaches 0 of sine of 5 theta over 5 theta times limit as theta approaches 0 of what? Of 2 theta over sine of 2 theta, like that. Now, remember I told you, as theta approaches 0, 5 theta should also approach 0, or 2 theta should also approach 0. In this case, it will be 5 theta approaching 0. Here it will be 2 theta approaching 0. Taking us to page 5, let me just complete this as quickly as I can. So, basically saying that this simplifies to, I move this one down a bit more, right? So basically I'm saying to you that this is the same as 5 over 2 multiplied by the limit as 5 theta approaches 0 of what? Of sine 5 theta over 5 theta times the limit as 2 theta approaches 0 of what? Of 2 theta over sine of 2 theta, and this simplifies to 5 over 2 in brackets there to be 1. Obviously you can see that that's 1, and that will also be 1 times 1. And what is 1 times 1? 1. So this simplifies to 5 over 2 as our final solution. Not very straightforward, but requiring a little bit of tricks from here going down until we are able to establish this result here, that result there, and take advantage of the fact that the limit as x approaches 0 of sine x over x must be equal to limit as x approaches 0 of x over sine x, which must be equal to 1. So this is what we're using here to come up with our 5 over 2 as our final solution. All right, I'm going to stop here in this video. Like I said at the beginning, if you're new to this channel, support us by subscribing, and your feedback is highly appreciated. All right, see you next time.